Good morning, children. Today we are going to see the third lesson in chemistry. What is that? Elements, compounds, and mixtures. Yes, now we are going to see the third part, which is the mixture part. Okay, elements, compounds we have already discussed. Now we are going to discuss about the mixture. What is this mixture? That is when two or more substances are combining but there is no chemical change. There is no chemical change between them. Then it becomes a mixture. The substances in the mixture are called as components. Example for a mixture is air, oil in water, sugar in water, alloys. Now, what is an alloy? Alloy is a mixture of two or more metals. It is a mixture of two or more metals. That is why it is called as alloy. You have an example, have steel, brass, bronze, all are alloys. So, mixture means two or more substances which combine such that no chemical change occurs between them. And the substances in the mixture are called as components. Example, air, sugar in water, alloys. And then what is an alloy? It is a mixture of two or more metals. See the picture. I have put some color beads together. Okay, orange color, yellow color, red color, green color. When I put them all together, it becomes a mixture. Why? There is no chemical reaction between them. Only the physical combination, or I'm putting them together physically, and then I can easily separate them. I can pick it out. Orange color beads separately, green color beads separately, red color beads separately, yellow color beads separate. Similarly, mixture is also a combination of substances where there is no chemical reaction between them. Now, what are the characteristics of mixtures? They do not exhibit any property on its own. Okay, the components don't lose their individual property, and then the components are not in a fixed ratio, and then they can be easily separated. So, mixtures are not pure substances. I repeat all the five characteristics. First one is they don't have any property of its own. The second one, they do not lose their individual properties. Yes, when the color beads are all combined, they are not losing any property of its own. They are not becoming liquid. They are not becoming black color. They retain their own individual properties. The components are not in a fixed ratio. There is no fixed ratio at all, and then they can be easily separated. And then mixtures are not pure substances. Now coming to the compounds and mixtures differences. First one, compounds. They are made of two or more substances, but they mixed chemically. Then they exhibit new properties. The ratio of the components is fixed in compounds. The components cannot be separated by physical means, and they are called pure substances. We have already seen examples as carbon dioxide and water in the previous class. Okay, so compounds, when two or more substances are mixed chemically, when two or more substances, whereas mixture, two or more elements that are not mixed chemically. Mixtures don't exhibit new properties, and then the mixtures, the ratio of the components is not fixed, and in the mixtures the components can be separated by physical means, and they are called as impure substances. Impure. So you have example, air, salt in water, and alloy. Air, salt in water, alloy. Now you have two types of mixtures. One is based on the distribution of the components, other one is the State of the component. State, we know, solid, liquid or gas. It is either based on the state or on the distribution. Distribution, how much is the concentration or something like that. We will see the types. First one is based on the distribution. We have homogeneous and heterogeneous. Homo, H-O-M-O, homo, gene, G-E-N-E, gene, os, O-U-S. Then hetero, H-E-T-E-R-O, hetero, genus, G-E-N-E, gene, us, O-U-S. So these are the names of the two types of mixtures based on the distribution of components. Now you should do first thing as write the spellings of this each five times, because it's a new spelling which is very large. You will be forgetting the spellings easily, so you should write the spellings each five times, and then only you can memorize. So the two types of mixtures, homogeneous and heterogeneous. When look at the picture given below, I have two color balls. One is the purple ball, other one is the green ball. Now the purple ball and the green ball are neatly arranged one after the other in the homogeneous mixture, whereas in heterogeneous mixture they are not arranged at all are just put as it is. Similarly, we are going to see the characteristics of in these mixtures in individually. Homogeneous mixtures, these are the components where distributed uniformly. They are distributed uniformly, and we cannot identify that individual components distinctly. Okay, now take the example I'll give you. I'll take salt solution or sugar solution. That is, you take a tumbler, take 1 spoon of salt, put it inside the water. You stir it. Stir it means with a spoon itself you mix it. What will happen? You only see the water or the liquid portion. You cannot see the solid which you have put inside. That means what has happened? The solid has got mixed well. Mixed well means it is totally combined with the liquid. So you cannot distinctly, that is, you cannot say that is salt and this is water. You cannot say anything. Even with the color, only in the taste you can say yes, the salt is there inside the water. Otherwise you cannot say the salt is this one and water is this one. So the components are distributed uniformly and they cannot be seen distinctly. Okay, then the properties remain same in all parts of the mixture. All parts, any drop of water you drink, it will be salty. If you just take it from the top of the tumbler or at the bottom of the tumbler, any place, the water will be tasting salty. And example, sugar solution, salt solution, alloys, S and then air. Then we come to the heterogeneous mixtures. Heterogeneous mixtures, the opposite of homogeneous, that is, they are not distributed uniformly, so we can see them distinctly. Okay, so the properties will differ in different parts of the mixture. Simply take chalk powder, or you can take sand. If you put sand inside the water, what will happen? It will all go and settle in the bottom, and water will be floating up. We can directly see and say the bottom is sand and the top is water. Similarly, when we put oil in water, oil will be floating. Oil will be floating. You can see the shiny layer on the top of the water. So you can distinctly separate those two things. So that is why they become heterogeneous. Heterogeneous mixture, and you have example smoke, oil in water, chalk powder in water, etc. Now coming to the types of mixtures based on the state of the components. We know solid, liquid and gases are the three states of the matter. Now, when a solid is mixed with a solid, and it is one type of a mixture. When a solid is mixed with a liquid, this is another type of a mixture. And then liquid and a liquid mixture. These three are the three types of mixtures. There are more types of mixtures, but in this 7th standard, we are learning only about these three. Okay, so solid and a solid mixture. You have the example of fruit salad. What is this? Fruit salad, you know. You cut different fruits, apple, banana, mango, strawberry, peach, grapes, pineapple. You cut all these fruits and you mix it. You can see those fruits with their colors. You can identify with their colors. You can separate them, and all the fruits retain their own properties. They don't mix chemically. So they are all characteristics of the mixture. Now coming to the solid liquid mixture. In this case, you take the salt and water example itself. And the third one is a liquid mixture. There you take water and a paint. See the picture down, you have water and I'm mixing the yellow paint there. So this is a liquid mixture. Okay, now we are going to see the separation of mixtures. That is how we are going to separate the components from the mixture. Why you want to separate? Because we have to get the useful components, we want to remove the unwanted components, and we can get any desirable substances. This is why we do separation. We don't simply do it simply. Okay, we get useful components, we remove the unwanted components, and we get desirable components. First, for getting the useful components, you can say we can say from the mixture, that is from the tea. When you make tea, you put tea powder, milk, water all together and sugar. Now you get the useful component as tea. Now you remove the unwanted components. You filter the tea so that the tea dust or the tea particles stand back. Only the liquid portion is the tea. And then you get the desirable substance. That is when you have mixed the sugar accordingly, then it is a desirable change. That is, you have added sugar to the tea. Otherwise, the tea will not taste good. Okay, so a useful component is the tea. Then we have removed the unwanted waste like the tea dust. And then the desirable component, because we are going to add sugar. Okay, so you can take the example of the tea for why we want to do the separation of mixtures. Now, how we are going to separate a solid and a solid mixture? Okay, a solid and a solid mixture. First one is a hand picking. Hand picking, you know, hand picking, you can pick it out with the hands itself. But we are now going to see about sublimation. Sublimation we have already seen. What is the process sublimation? It is a process in which a solid changes directly into a gaseous state. A solid will directly go to the gaseous state without going to the liquid form. So when we have this property, we are going to use this property when we are separating the solid mixtures. That is, we take two solids. Out of that, one solid will have this property of sublimation, or it is called as sublime, a solid that can sublime. In on that case, we can go with this separation. Look at the picture. What is that? You have a burner, that is a burner which will be burning, okay, like our gas burner. Okay, on the top you have a china dish. China dish is made up of porcelain or glass. On the thing you place your camphor or this mixture mixed with camphor. That is, you can take salt and camphor, both are solids. Or you can say sand and iodine, both are solids. You mix both those salts. Okay, then place it on the china dish. Now when before heating, I'm going to invert one funnel, a simple funnel, and at the end of the funnel you put a cotton plug. Cotton plug means you insert cotton, because the waves or the fumes or the smoke should not go out through that opening of the funnel. Okay, now what I do, I start the burner and I heat the mixture. Then the camphor or the iodine in the mixture will start converting into gaseous state. That means you get fumes. Fumes means small waves like that. It will start coming up. Then they all are collected on the what? Funnel. In the funnel, on the walls of the funnel, you can see they are deposited. So this is how we will be separating a solid and a solid, especially the solid which should be a sublime solid. Okay, example camphor and iodine. Now coming to a solid liquid. Solid is mixed with a liquid. Here you have evaporation and distillation. This is a case where the solid is soluble. Soluble means it is totally combining with the liquid. You cannot say they are different at all. Like the example salt and water or sugar in water. They are totally soluble in water. Now, evaporation we have already seen. We mix salt and water and we place it under the sun or you heat it again using the burner. What will happen? Water gets evaporated, only the salt is left behind. Okay. Now coming to the distillation. What is this distillation? You have heard this word distill. Where is that? In the form of distilled water. Yes, everybody will have UPS at home. Yes, whenever the current goes off, you have this UPS backup for giving the light power to the house. In for this UPS battery, we have to pour this distilled water. Why not simple water? We are going to pour distilled water because distilled water will not have any salts, because our normal water, rainwater or river water or this any water will have salts present in. We are going to remove the salts through this distillation and you will be only getting the water alone. So that is why it is called distilled water. Why we want distilled water for the batteries? Because this salt will go deposit on the battery anode and the cathode, and they will not conduct the electricity properly. So that is why we have to pour only the distilled water. So now how we are going to get the distilled water? You because we are going to use a special apparatus. Okay. Now I pour the salt water or the sea water in a distillating flask. This distillating flask is the round flask which is at the left hand side. Now this flask cannot stand like that, so we have to have attach it to a stand. Now under the stand you are going to heat it. Okay, when I heat it, on the top you have a thermometer fixed inside. Okay, now at the side you have a tube. Yes, you have the tube, and then the tube is coming out and giving the water, which is called as distillate. And on the tube, that is called the distillating tube, on the tube you have the water inlet and the water outlet, and that tube is called as condenser. That is called as condenser. Here the process is what? You are evaporating, that is you are going to heat the water. Water will get evaporated. Now that evaporated gas or the gas is now condensed back. How is it condensed? I'm going to cool it down. When I cool it down, it will become liquid. So that is the principle used behind this distillation apparatus. Okay. Now coming to the liquid to liquid separation. That is, I'm going to use separating funnel or I'm going to use the fractional distillation. What is this separating funnel? It is for immiscible liquids. Immiscible. 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 You can write this also the spellings. Immiscible means they don't mix well. Okay, like the oil and water. The moment you mix oil and water, you know oil will be floating, water will be below. Whereas for miscible liquids, that is, both the liquids are mixed well. You take milk and water, they are mixed well. you go for fractional distillation. Separating funnel, that is, it is a funnel. You look at the picture, it is the funnel, and it will have a stopcock. Stopcock is you can stop it. Okay, the moment you pour or you mix oil and water and you pour that into this separating funnel, water will settle down, oil will be floating up. Oil is in orange color, water is in blue color. Now I open that tap like thing, that is called a stopcock. Now I open that and I allow water to come down, or I am going to filter the water alone. So only the moment the oil area reaches, I stop it. So I have separated our water and oil. Now coming to the fractional distillation part. Fractional distillation, I mean, we are going to separate the liquids one by one from the mother mixture. Okay, mother mixture here is one big mixture. From one big mixture, I'm going to take one by one. Okay, so this is first is the miscible liquids. Miscible liquids here is the crude oil which we get from the earth. You take that crude oil and I'm going to put that in the fractional distillation chamber. This is a huge chamber. It will be built in a big it will be built as a big apparatus. There, when I pour the crude oil at the top, you have to come from the top. So when I heat it to 20 degrees Celsius, you will be getting only the gases. Those gases are used for our cylinder. The next one, when I heat it to 70 degrees Celsius, there I get our chemicals, petroleum products. And then when I heat it to 120 degrees Celsius, I will be getting the petrol. Then when I heat it to 170 degrees Celsius, I'll be getting torsilene, or the fuels for the jet, aeroplanes, etc. Then when I heat it to 270 degrees Celsius, I will get diesel. Okay. Then when I heat it to still further, when I heat still further, I will be getting the petroleum lubricants, like wax, oil, etc. Then at the last, you will be getting the residue. The residue I can use for the road construction or anything. Okay. Now, whenever I am heating, what will happen? According to the temperature of heating, I can get these different products. Okay, so that means the difference is on their boiling points. Whenever I reach that boiling point, I get that particular substance. Then if I increase my boiling point, I'll get the other substance. Okay. Now coming to the chromatography. Chromatography, this is one different separation technique where you have two phases. One is a stationary phase, other one is a mobile phase. That is, I am going to put a paper that is called chromatic paper. I am going to put that inside this mixture. That particular pigments will get attached. Pigments or colors, they will get attached to the paper, and the remaining liquid is left off. Okay, now we'll see the example of paper chromatography. We are going to use a particular kind of paper, and then it is based on the absorption of the individual components. That is, the paper will absorb the components individually. Okay, they are used mainly to isolate plant pigments. You have the colors in the plants, right? The leaves are green in color, the fruits are red, or flowers are red in color. So these colors are there in the plant because of certain pigments are there in the plant cells. So how we are going to separate the pigments? Using this paper chromatography. That is, you get all the colors differently. You place that paper inside that solvent with that particular leaf. That is, you take the leaf, flowers, everything, you mix it along with one chemical called acetone, and then you put the paper inside. Then the leaf extract will be spotting one by one. First one is the um, chlorophyll B, that is the dark green color. Light green is chlorophyll A. Then carotenoids, you have the the orange color. Then the xanthophylls, that is a gray color, and there's another also carotenoids. So all these are all different pigments which are all getting deposited on the paper. Okay, children. Now you have to say true or false for the given sentences, and you have to submit this as homework. Last week I did not get the homework from you as a proper submission. Please do this homework and submit it. Okay, children? Thank you.